Okay, guys, in this part of the lesson, we are going to use our justifications to show why we do what we do as we're solving. So here we have a two-column proof, the statement column and the reason column. This over here is just workspace. Now, whenever we complete a two-column proof, you will not show any work in the columns. If you need to work something out, then do it over here in your scratch work area. So the first statement is always going to be the problem itself. You're going to write the problem just like you see it. And the reason for our first statement is always because it was given to us. So our statement is the problem, our reason is it was given. Now, before we can solve this, you can see that we can combine like terms. So on my next line, I'm going to go ahead and combine these. I can do this in my head. I don't need my scratch work area. And then the reason that we have this new statement is because we were able to combine like terms. The next step is we have multiplication and then we have subtraction. So we're going to undo this. So we're going to do the opposite of order of operations. So we're going to add 12 to both sides. So the reason that I can do this is because of the addition property of equality. Addition because we're adding 12 to the left, making us have a 0 constant here. And then we're adding to the right, which is going to give us a 28. And the equality part is because I did it to the left, I also have to do it to the right. We have to be equal to both sides. Now we have 2/3 times x. So to undo multiplication, we are going to use the division property of equality. I'm going to use my workspace to show division. So we are dividing both sides by the 2/3. So anything divided by itself cancels out. But dividing is the same as multiplying by the reciprocal. So 28 divided by 2/3 is the same as 28 times 3/2. Now, when I am multiplying a fraction times a whole number, I always try to see if the denominator can divide into this integer, and it can. It gives 2 divided into 28 gives me 14, and then now I multiply it by the numerator. So I get x is equal to 42. And this is my one solution. So we can say exactly one solution. There's only one number that if I plug back into my original equation for x, the left side will equal the right side. Okay, our second problem, we're going to write this in our first statement line, just like you see it. Don't be tempted to do any simplifying. You write it just as it is. And the reason for that is because it was given to us. Now, we have a few things we can do, but we can only do one reason at a time. So here we have parentheses. So remember, we have to always dissolve the parentheses before you can do anything else. So I'm going to multiply 3 times x and 3 times minus 2, and I get 3x minus 6 plus 5x equals 8x minus 24. So that reason was the distributive property. Now we can combine like terms on the left, 3x plus 5x, that's 8x minus 6 equals 8x minus 24. And we did that, we got this statement because we combined like terms. Whoops, no D there. Okay, now remember, because we have variables on the left and the right, we have to deal with the variables first, not the minus 6 or not the minus 24. So I have 8x minus 6 equals 8x minus 24. We always want to get rid of the smallest one, but in this case, they are the same. So when we subtract them out, we get a statement with no variables and a false statement. So this was the subtraction, because I subtracted, property of equality. And we're left with a false statement, so we're going to say there are no solutions. Okay, the next problem, let's write this in our statement. And our first reason is always because it was given to us. Now, we must distribute, and we just can distribute on the left and the right. So I'm going to go ahead and put the reason, so distributive property. And I will show my work for this one right here. Okay, so again, 4 can divide into 12. It goes into 12 3 times, and then 3 times 3 is 9, so I have 9x. And then 4 divides into 25 times, and then 5 times this 3 is 15, so that's plus 15. Bring down my minus 12 equals, and I can go ahead and distribute the same property. So as long as we're using the same one reasoning, we can do both of these. Now we can see that we need to combine like terms here. So I got this statement because we applied combining like term property. So combine like terms. Now we see we have a variable on the left and a variable on the right. So I'm going to subtract those out. And when I subtract 9x and 9x, I get 3 equals 3. So that was the subtraction property of equality. And I'm left with no variables in a true statement. So this has infinite solutions. Anything will work to make my equation true. Okay, here we have a multi-step problem. So our first reason, it was given to us. There's no parentheses, there's no combining like terms, there's no variables on both sides, so we're simply straight up solving. So I'm going to write the order of operations that I would use if I knew what x was. So x was squared, then we would multiply by 2, then we would add 6, then we would divide by 3, and fifthly, we would subtract 12. Now, let me tell you something. When you have this big long division bar, this acts like these top terms are in parentheses, and if we had more than one term on the bottom, they would be. So this long division bar acts like parentheses. So that's why we would do all this first and then divide. Okay, so we're going to work backward, and we're going to get rid of the subtraction by adding. We're going to add 12 to both sides. And when I do that, I eliminate the minus 12 on the left, and then I get 26 on the right. So this was the addition property of equality. Okay, so we did this. Now we're going to get rid of, so I have 2x squared plus 6 divided by 3 equals 26. Now we're going to undo division by multiplying both sides by 3. And the 3's cancel, leaving me with 2x squared plus 6 equals, and then 3 times 26, that's going to be 78. So that was the multiplication property of equality. Okay, so we have 2x squared plus 6 equals 78. So we undid the division. Now we're going to undo addition. I'm going to subtract 6 from both sides. And I get 2x squared equals 72. That was the subtraction property of equality. Okie doke. So we undid the addition. Now we have to undo the multiplication. We have 2 times x squared, so we're going to undo multiplication by dividing. So we get x squared equals 36 by the division property of equality. Okay, and then the last thing is we have to undo the squaring, and we're going to take the square root. And remember, when you take the square root, there are 2 roots to a perfect squared number. So taking the square root, undo squaring, that's what gives me the x by itself. And then I have positive 6 and negative 6 as my 2 answers. So x equals plus or minus 6, and that was the square root property of equality. And we have exactly 2 solutions. Positive 6 and negative 6 will make the left side equal the right side. We will have a true statement with either one of those values.